Hi there, Mr. Biggers here, and today we're going to start our packet on Module 1, Lesson 2, Linearity, Intercepts, and Symmetry. So in a linear function, no variable is raised to a power any other than 1. So a note that we might want to make to this is x is only to the first power. Okay? So an example of a linear function would be an equation like slope-intercept form, y equals x. It's going to make a straight line. So that's another thing here, okay? Linear equations can be written in standard form or slope-intercept form, both of which we learned about in class already. A function that is not linear is called a nonlinear function. The graph of a nonlinear function includes a set of points that cannot all lie on the same line. A parabola is the graph of a quadratic function, which is a type of a nonlinear function. So a parabola kind of makes a smiley face or a frowny face. So we have lots of vocab off to the side, and I just want to go ahead and make some sketches so that way we have some reference for our vocabulary. So linear functions, linear equations, going to make a straight line. A nonlinear function is going to be like a curvy line. A parabola is like a smiley face. An intercept is going to be, so your x-intercept would be where you hit your x-axis. Your y-intercept is where you hit your y-axis on a graph. Okay? And then we have all these symmetries. Line symmetry is if something can be cut in half, okay? Or something is symmetric about itself. So like this triangle, if I drew it right, could be cut in half and fold on itself. It's symmetric, okay? And then even functions are going to, this is new here, even functions are going to point the same direction. Okay, so either a smiley face or a frowny face. Odd functions are going to do the opposite. So they would point different directions. So an example would be this or this. Both of those are odd functions. So even functions are going to point the same direction. Odds are going to point different directions. Okay, so moving on here, we are going to identify linear functions just from equations. So determine whether each function is linear. Justify your answer. Okay? So we are going to look through the steps here. So they had f of x equals this. What they did here was they went ahead and just simplified it. So 6x over 3 minus this. So 6 divided by 3 we know is 2. So we get 2x minus 5/3. That is a linear function because it is written in the form of slope-intercept form. So it is definitely a linear function. The function can be written in slope-intercept form, so it is a linear function. Also, your x is to the power of 1. Okay? And part B here, pause the video, see if you can figure out if it's linear or not. Okay, we're going to go ahead and go over it now, though. So just rewriting it, we're trying to get it in slope-intercept form. We have this when we rewrite it, okay? So since our x is to a power that's not 1, the function cannot be written in the form, the slope-intercept form, because the independent variable x is raised to the whole number power greater than 1. So it's raised to the power of 3, therefore it's not a linear function. It's a non-linear function, not a straight line. So another note I would add is a linear function is a straight line. Next page.
Rocks, lights, out of sight. Students, move to the hard corner of the classroom. Maintain silence. Do not open the door. Staff, recover students from the hallway if possible. Lock the classroom door. Turn out the lights. Move away from sight to the hard corner of the classroom. Maintain silence. Do not open the door. Hard lockdown drill.
Why do you say drill? Did you hear that? Okay, so on example 2 here, we're going to determine whether each graph represents a linear or non-linear function, okay? So over here, let's do the think about it really quick. Why is this a not linear function? Okay, so think about a square root. If you have a square root, that can be rewritten to the power of 1/2. And that means that x would literally not have an exponent of 1. It would be an exponent of 1/2, which means that equation would be nonlinear. So it's not a straight line, nonlinear. Okay, so if we're talking about over here, though, on these examples, we need to see pretty much, is this a straight line, yes or no? The answer is not a straight line. Okay, this is nonlinear. There is no straight line that will contain the points A, B, and C. Therefore, it is a nonlinear function. All right, look at part B here. You can see here that it is a straight line. So this would be linear. It's pretty simple. Okay, so it is a straight line. It's going to be linear. The parent function for this graph would be this. That's your basic function for a straight line. We already learned here absolute value. The parent function for that would be this. So when I say parent function, that's the most basic type of that type of function, okay? So that would be an absolute value function over here on the top, and the bottom one would be a linear function, or like y equals x, okay? So real quick here, we're going to look at example 3. So we have Michaela here, and she's starting to work her part-time at the local hardware store. Her and her work steadily increases for the first 5 weeks. The table shows her earnings each of those 5 weeks. Are her weekly earnings modeled by linear or nonlinear? So if the distances or if the rate of change are equal, then it's linear. So if rates of change we'll just say steady. If rates of change are steady, then linear. Okay, so we're gonna, when I say rates of change, I'm looking for the weeks and the earnings. So week 1 to week 2 adds 1. Week 2 to week 3 adds 1. And so you'll look here, that is a steady rate of change. It's gonna keep going up by 1 each time, okay? Now if you look here to here, if you do the math, that's going up by 34. Each time here, you can check it, it's gonna keep going up by 34. And so if it does that, it is a linear function, okay? If you graph all these points, you'll see that it creates a straight line. So I'll go ahead and graph it. 1 and 85 would be right about here. 2 and 119. 3 and 153. 4 and 187. And 5 and 221. So you can see here, it pretty much makes a straight line. So this is modeled by what type of function? A linear function. It's a line. So if distances are, if the rates of change are steady, then it's linear. That's the important thing to know here. All right, we're going to get through example 4 and 5, and then we're going to be done. So example 4, at a point in which the graph of a function intersects the axis is called the intercept, and x-intercept is the x-coordinate of a point where the graph crosses the axis. So we already know what x-intercepts and y-intercepts are. So here we're going to come down here. We're going to look at the x and the y-intercepts. So the x-intercept of this graph would be at 0, 0. The x-coordinate of that is 0. So that means the x-intercept is 0. The y-intercept of that is at 0, 0. So the y-intercept is 0. The y-coordinate there is 0. Okay? So that's example 4, pretty easy going. Example 5 is use the graph to estimate the x and y intercepts. So if you look at the graph here, if we look at the x-intercepts, it hits here, here, and here, and it hits the y right there. So it appears to intersect at those 3 points, -3, 0, -1, 0, and 2, 0. So it has the x-intercepts of -3, -1, and 2. Okay, so you're looking at the x-coordinates of those points where it intersects. Same thing for the y. It intersects at in between 8 and 16 would be 12. So the point there, the x-coordinate would be 0. The y-coordinate is 12, so it has a y-intercept of 12. Okay, try the check. So freeze the video, try the check, see if you can figure it out. The x-intercept, so where I cross my x-axis is right here, and if you look, that has a point of the x would be -1, 2, 3, 4, 5. So -5, comma 0. So the x-intercept is -5. The y-intercept would be 2. And we'll check this one too. So you have 1, 2, 3, 4, 5 x-intercepts here. So it'll be at -4, -2, 0, 3, and 5. And the y-intercepts is going to be at just 0 right there, because it only hits the y-intercept one time, right at 0. All right, and that's the video for the day 1 notes.